Welcome to today's math lesson on finding the volume of spheres. Our TEK is 8.7a. Our do now question reads, the graph of a linear equation is shown. Which equation best represents the graph? So my first step is to identify what the y-intercept is. So it's at this point right here, which looks to be positive 2. So our b value is 2. When I look at the answer choices, all of the y-intercepts are at 2. So now I need to find another point that is at the intersection of the grid. So right here, I'm choosing that point. And then I need to find my change in y over my change in x. So from left to right, I'm going down. So that means I know that my change in y is going to be negative because if I'm going down, that means that it's negative. So I'm going down 1, 2, 3, 4 units. So my change in y is going to be negative 4. And then my change in x is going to be 1 unit to the right, so that's positive 1. And then I can simplify negative 4 divided by positive 1 to be negative 4. So I know that my slope is going to be negative 4. So the only one that has a slope of negative 4 is C. Today's TEK, again, is 8.7a. Our lesson target is that scholars will solve problems involving finding the volume of spheres. And our DOL is given 4 problems. Scholars will solve problems involving finding the volume of spheres with 100% accuracy. Before we get into today's problems, we have some academic vocabulary words to go over, such as the word sphere. A sphere is a circular shape that's 3-dimensional, as you can see right here. So balls are usually in spherical shapes. The radius, as we've been going over, as we've been finding the volume of cylinders as well as the volume of cones, is going to be the length from the middle of a circle to the end of a circle. The diameter is the length from one end of a circle to the other end of the circle. So the diameter is usually twice as long as the radius, or the radius is half as long as the diameter. Cubed is another way to say that a number is raised to the power of 3. So r cubed is the same thing as saying r to the power of 3. And we've been finding the volume of different 3D shapes all week. So just as a review, the volume of a cylinder can be found by multiplying pi times the radius squared times height. To find the volume of a cone, you can multiply 1/3 times pi times radius squared times height. And to find the volume of a sphere, what we're learning about today, we're going to be using the formula 4/3 times pi times radius cubed. So for this first algebra problem, it says we have to find the volume of the sphere, this one right here in this diagram. This right diagram just shows the 3-dimensional nature of spheres. Round your answers to the nearest tenth if necessary, and we have to use 3.14 for pi. So the first thing that I'm going to do, that I have been doing for all the volume equations or the volume problems, is writing out the volume formula. In this case, the volume of a sphere is V is equal to 4/3 pi radius cubed. My next step is to plug in the appropriate numbers. So we have V is equal to 4/3. And for pi, we're going to plug in the number 3.14. We're going to substitute, replace pi with the number 3.14. And in this case, we have our radius, which is 11. So then we're going to write 11 cubed, or 11 to the power of 3. My last step is to calculate or plug in 4/3 times 3.14 times 11 times 11 times 11 to get my volume. And so when I do that, and I round it to the nearest tenth, I get 5,572.5. And my unit of measurement in this problem is centimeters. And again, or because we're finding the volume, it's going to be cubed, since a sphere and the volume is for 3-dimensional shapes. My next algebra problem is a word problem. So it says fossilized spherical eggs of dinosaurs called titanosaur sauropods were found in Patagonia. These eggs were 15 centimeters in diameter, and we have to find the volume of an egg, and we have to round our answer to the nearest tenth. So our first step in solving volume problems is to write out the volume formula for the shape. So since we're finding the volume of a sphere, our equation is 4/3 times pi times radius cubed. Our second step is to plug in the appropriate numbers. So in this case, this problem doesn't tell us to use 3.14 as pi, but we just know that that's what we have to do. So we have v is equal to 4/3 times 3.14. And in this case, we can't plug in the 15 into our radius because the 15 is our diameter. So if we remember from the last couple of days worth of lessons, our diameter is twice as long or twice as big as our radius. So our radius is going to be half of our diameter. 15 divided by 2 is 7.5. So then we can plug in the 7.5 and raise that to the power of 3. So when we calculate this volume, we're multiplying 4/3 times 3.14 times 7.5 times 7.5 times 7.5. And then when we round our answer to the nearest tenth place, we get 1,766.3. Our unit of measurement in this problem is centimeters. And we have to remember to raise the centimeters to the power of 3, or our unit is going to be centimeters cubed. There are several we do problems as well as you do problems. And finally, you guys will have to answer 4 problems on a Google Form DOL. Thank you so much for following along in today's math lesson, and see you in tomorrow's video.